Let's start with today's session. Yesterday, if you were remembering, what we discussed? Let's check. Yesterday we discussed about velocity, the formula V equal to R omega. Is it right? This formula we discussed yesterday. Then after that we discussed one more formula, that is acceleration. What is acceleration? R alpha. Is it right? R alpha. But before discussing formula for velocity V equal to R omega and A equal to R alpha, we discuss one concept, that is UCM, means uniform circular motion. What is that uniform circular motion? Can you type it in chat box? What is uniform circular motion means? UCM, motion having uniform linear speed or uniform angular velocity. Or in other words, angular velocity will remain constant. Angular velocity will remain constant. Linear speed or constant angular velocity. Now, angular velocity is going to remain constant. Angular velocity means omega. Is it right? This omega is going to remain constant. What is formula for alpha? Basic formula for alpha which we discussed is the formula for alpha is change in angular velocity, that is omega 2 minus omega 1 upon t. This is the formula of alpha. Is it right? Now when omega is going to remain constant, omega is going to remain constant. It is not going to change at all. So what will be the value of alpha? Yes, when omega will remain constant, what will be the value of alpha? Because what is alpha? Change in angular velocity upon time. Yes, I am waiting. Yes, very good, Sridhar. He typed 0. Minal also typed 0. So it is 0. Alpha is 0. Alpha means angular acceleration is 0. And when alpha is 0, what about this acceleration? Tangential. This acceleration is also known as tangential acceleration. This tangential acceleration is also 0. Is it right? Now the question will arise, when acceleration is 0 and then also body is moving. See, when acceleration is 0, what about force? What is formula for force? Mass into acceleration. Is it right? When acceleration is 0, force is also 0. And body is in motion. Can body remain in motion if force is 0? No. Body cannot remain in motion if force is 0. Yes, Meena and Ashish answered correctly. That is, body cannot move. But over here in circular motion, body is moving. Though angular acceleration is 0 and tangential acceleration is 0, body is moving. What it means? Its meaning is body is moving means there should be some another type of acceleration present. That acceleration is another acceleration than alpha and at. So that acceleration, we are interested in that acceleration which is another acceleration than at and alpha. But now, just suppose you are a scientist, then you also can think the same thing, that is, there is a circular motion. Is it right? See, there is a circular motion. So whenever there is circular motion and the object is moving along circumference, means like this way. So is this object is moving around a common center? Is it right? So an object is moving around a common center, there should be force present at the center. There should be force present at the center. So when force is present at the center, what should happen? The acceleration should be from center. So this object or this center is going to exert acceleration towards this side, towards the center. So scientists called it as centripetal acceleration. Why centripetal? Centripetal means center seeking acceleration. Centripetal means what? Center seeking acceleration. And we are interested in the center seeking acceleration, that is centripetal acceleration. Let's concentrate on the centripetal acceleration now. Okay, sorry. Acceleration of body in UCM, that is centripetal acceleration of body in UCM. First, there are two methods. We are going to study vector method over here. Now, just pay attention carefully. Consider an object which is at point A. After some time, that object is performing which motion? Circular motion, UCM. In which sense? Clockwise sense or anti-clockwise sense? It is shown over there in the diagram. Yes, anti-clockwise sense. So consider an object performing UCM in anti-clockwise sense. Initially, that particle is at point A. After some time, that particle will reach at point B by covering angle delta theta. Okay, initially particle is at point A. By covering angle delta theta, it will reach at point B. Velocity of particle at point A is vector VA as shown over here. See, this is a vector VA. Okay, and at point B it is vector VB. Now, according to laws of scalars and vectors, we can shift any vector from one point to another point without changing its direction and magnitude. So this is vector PA. We can change position of PA from one point to another point, that is suppose at point B, means I am going to displace that vector and I am going to place at point B. Then it will be BQ. Over here at point A it is PA. When you will place it, there is a little mistake in the diagram. It should be, when this is a straight line, this is tangent over here. Okay, so this should be straight line over here and like this way, but by mistake it is tilted over here like this way. Okay, getting it? So BQ is the transferred vector from PA. We transferred vector AP or from AP to BQ. Any doubt till this point? Getting this part? Okay, Minal asked why we are transferring it. See, Minal, we want to find out acceleration. Is it right? So when we want to find out acceleration, we have to concentrate. What is the formula for acceleration? Change in velocity upon time. So we have to find out change in velocity. What we have to find out? We have to find out change in velocity. And that's why we transferred vector AP, that is vector VA, from A to point B. Now getting it to you, Meenal? Okay, very good. Then, now I want to discuss you one more thing. See, when angle AOB is delta theta, angle between QBR is also delta theta. Angle AOB is delta theta, QBR is also delta theta. How? If you are having this doubt, how that is delta theta? So for that purpose, there are two vectors. See, this is AP and this is radius. AP is a tangent. So tangent and radius, angle between tangent and radius is 90 degree. Is it right? When this OA means radius will reach at point OB, OA will reach at point OB. Then again, when OA will move like this way, AP will also move like this way with OB to maintain angle 90 degree. Is it right? So when OA is going to cover angle delta theta, obviously AP will also move with angle delta theta to maintain angle 90 degree. 90 degree between OBR. Are you getting how when AOB is delta theta, then QBR is also delta theta. Over here, angle is how much? See, this angle is 90 degree. Angle PAO is 90 degree. Is it right? Then angle OBR is also 90 degree. Now it's very simple. See, OA is covering angle delta theta and it will reach at OB. When OA will displace with angle delta theta, AP should also get displaced with delta theta, no, to maintain this angle 90 degree. If it will not get displaced with delta theta, then what will happen? Then initially angle is 90 degree. Suppose if it will not get displaced like this way, his angle will remain 90 degree. Or if it displaces more, then his angle will remain 90 degree. No. When angle will remain 90 degree between radius and tangent, when radius will move with angle delta theta, tangent should move with angle delta theta. Now, again I will explain the complete diagram. Consider UCM in anti-clockwise sense. Initially, particle is at point A. After some time, particle will reach at point B by covering angle delta theta. Let vector R be the radius vector or position vector. OA is the radius vector and AP is velocity vector, that is vector VA. At point B, the velocity vector is vector VB and that is equal to RB. We can displace any vector from one point to another point, so without changing its direction and magnitude. So displacing AP from AP to B means we are going to displace this AP to B and we are going to change its name from AP to BQ. We are going to change its name AP to BQ. So angle between QBR is also delta theta. I will proceed further. Now, over here, according to triangle law of vectors, vector BR, what is the triangle law? If you are remembering, see, I will revise the triangle law quickly and then I will proceed. See, suppose this is vector A, this is vector B and this is vector C. So, we discuss this vector triangle law, that is vector A plus B, vector B is equal to vector C. Is it right? Vector A plus vector B is equal to vector C. This is triangle law. Now, over here there are three vectors. Which three vectors? BQ is the first vector. BR, this is the second vector, and QR, this is the one more vector. So if we are going to travel in sequence, then BQ is first, QR is second. Is it right? See again, triangle law. This is first vector, this is second vector, no? So which vector is second vector? the vector which come after arrow, that will be the second vector, one after the another. So over here, this is the first and this is the second. So first vector is vector BQ and second vector is vector BR. So vector BQ, first vector plus second vector is equal to third vector. So vector BR, let's check the diagram once again. Vector BR is equal to vector BQ plus vector QR. BR is equal to BQ plus QR. Okay, so to the next step, QR equal to BR minus BQ. So what is BR? BR is velocity at point B. What is BR? BR is velocity at point B. And what is BQ? BQ is velocity. Actually, BQ is nothing but a transfer vector, no? From point A to point B. Is it right? So obviously, BQ is velocity at point A. So velocity at point B minus velocity at point A means what? Velocity at point B minus velocity at point A means change in velocity. So vector QR is equal to change in velocity, that is vector delta V. So we proved this complete part that to show that vector QR is nothing but the change in velocity. Why we worked on change in velocity? What is the formula for acceleration? Change in velocity upon time, no? Is it right? So that's why first we proved QR is change in velocity. Now acceleration is time rate of change of velocity. Acceleration is rate of change of velocity. So vector dv delta v upon dt. Is it right? Let's proceed further. Instantaneous acceleration can be obtained by limiting. Now delta v by delta t is average acceleration. Instantaneous acceleration is limit delta t tends to 0 is equal to, sorry, delta t tends to 0, vector delta v upon delta t. Then let's concentrate on this triangle QBR. Now I can prove that when this is delta theta, this is also delta theta. How can I prove? See, if these two triangles are similar, then angles are also same, no? Angle QBR, sorry, QBR, this angle is same to angle AOB. Let's assume that this is a triangle. Okay. Now is this radius and velocity is going to change as magnitude of velocity? No, they are not going to change. Is it right? So the ratio of this side is similar to this side and this side similar to this side. So obviously these two triangles are similar, and when these two triangles are similar, when this is angle delta theta, this is also angle delta theta. Okay. Let's proceed further. Now I am going to concentrate only on this triangle, that is QBR. I am going to concentrate only on this triangle, that is QBR. Okay. Angle between tangent is angle between corresponding radii. As delta t approaches 0, B approaches to A, and delta t becomes so small that we can write, see, we can write delta V. Now we are going to concentrate angle equal to arc upon radius, no? So this is delta theta, this angle is delta theta, angle delta theta equal to arc. Arc is QR is arc, and that is nothing but delta V. So delta V upon radius. Over here, what is the value of radius? Radius is nothing but a BQ and BR are the radius. Is it right? BQ and BR are the radius. What is value of BQ and what is value of BR? Its velocity. So divided by V. Delta V is equal to V delta theta. Are you getting till this point? If yes, then please click on agree. If you are having any doubt, if you are not getting it, you can click on disagree, because it is little bit difficult, tricky point. Did not get the slide. Okay, I will explain once again. Which triangle we are going to consider? Only BQR. Is it right? When we will consider this angle is delta theta. Which motion is this? Uniform circular motion. Is it right? In uniform circular motion, magnitude of velocity will remain constant. So when magnitude of velocity will remain constant, length of VA and VB are same, or they should be same. Is it right? So angle delta theta equal to arc. Arc is delta V, no? Okay, so delta V, and now divide by radius, arc upon radius. But over here, see, radius is for this delta V, this is nothing but the radius. Is it right? For the delta V, QB and QB and BR are the radius. How they are radius? Meenal asking. Meenal, okay. Now, I will tell you one more thing. Over here, velocity is this. Over here, at point B, velocity is like this. Over here, at another point, velocity is like this. Over here, at this point, velocity is like this. Is it right? Velocity is like this way. Now, if we will arrange all these vectors, this is one at a common point. This is second, that is this B vector. C point vector is this, and D point vector is this. And if you are going to join all these points, then obviously these all velocities are going to become radius. Is it right? If you are going to join, this is one tangent, this is another tangent at point B, this is another tangent at point C, this is another tangent at point D. If you are going to collect all these tangents at a common point, then it will create a circle. Is it right? So obviously these all tangents will become radius in that situation. Is it right? Or in, okay, so that's why VA and VB are the radius. Or if you are going to check this diagram, see, it is small curve, and when curve is small, it is you will see it in a straight line. Okay, so it is nothing but a radius. So angle equal to arc, that is delta V upon radius V. So delta V is equal to V delta theta. Is it right? So can I substitute this V delta theta over here? After substituting this V delta theta over here at the point of delta V, velocity is a constant per factor. Why constant? UCM in uniform circular motion. Velocity is constant. You can take it outside. So V limit delta t tends to 0, delta theta by delta t. But what is this? This is nothing but angular velocity, omega. So the formula will become V omega. Centripetal acceleration is equal to V omega. Now, substituting v equal to r omega. So if you will substitute at the place of v, you will substitute r omega, then it will become r omega square, is it right? If at the place of omega you will substitute v by r, at the place of omega you will substitute v by r, then v into v by r, it will become v square by r. So there are three formulae for centripetal acceleration. One formula is v omega, second is r omega square, and third is v square by r. These three formulae are formulae for centripetal acceleration. I will explain it from starting once again quickly. See how to write the answer of this question. First of all, you have to draw this diagram. After drawing diagram, you have to mention, that is, or you have to write description of diagram. Consider a particle performing UCM in anticlockwise sense. Initially, particle is at point A. After some time, particle will reach at point B by covering angle delta theta. Velocity of particle at point A will be vector VA, and velocity of particle at point B is vector VB. Vector VB is equal to vector BR and vector VA is equal to vector AP. We can move any vector from one point to another point without changing its direction and magnitude. Therefore, we are going to change the position of vector PA to BQ without changing its direction and magnitude. Then QR be the change in velocity, and to prove that QR is the change in velocity, we use triangle law. According to triangle law, vector BQ is equal to vector QR. Sorry, vector BQ plus vector QR. BQ plus QR is equal to vector BR. But vector QR is equal to vector BR minus vector BQ, is it right? Then what is BR? BR is velocity at point B and BQ is velocity at point A. So velocity at point B minus velocity at point A, it will indicate that vector QR is nothing but change in velocity. We want to find out acceleration. So acceleration is change in velocity upon time. So delta V upon T. Is it right? Then when it is delta V upon T, we are going to use very basic concept that by considering triangle or by considering a very minute circle, part of circle, that is BQR or QBR. So angle equal to arc upon radius. So delta theta is equal to delta V upon V. So delta V is equal to V delta theta. So at the place of delta V over here in the formula of acceleration, we will substitute V delta theta. But that velocity is constant, so you can take it outside of limit. So after taking it outside of limit, delta theta upon delta t, limit delta theta upon delta t by delta t tends to 0 is angular velocity. So our formula will become V omega. At the place of V, we will substitute R omega, so it will become R omega square. At the place of omega, we will substitute V by R, V divided by R, so it will become V square upon R. Getting it? But the question will arise, how can we find out direction of this acceleration? So to find out direction at acceleration, so this is point A, this is point B. This is velocity vector at point A and this is velocity vector at point B. So let's transfer this velocity vector at point B as we transferred initially when we were discussing the formula. We transferred vector from point A to point B, is it right? Now this vector we are going to transfer over here as shown in the second diagram. While transferring it, are we going to change the direction and its length? No, we are not going to change its direction and length. So this is nothing but, this line is nothing but change in velocity, no? So change in velocity is moving towards the center, is it right? This change in velocity is moving towards the center. Obviously, this acceleration will also move towards the center. Just we discussed, we can move any vector from one point to another point. Is it right? So this is velocity vector at point A and this is velocity vector at point B. So velocity vector at point B, I transferred from this point to this point over here, as shown in second diagram. Now where this is this red line, or over here this blue line, what this blue line will indicate, or in which direction this blue line is moving? Is this blue line is moving towards the center? So that delta V is moving towards the center, therefore acceleration will also move towards the center. Okay, so let's proceed further, and there is one MCQ. Please type your answer in chat box quickly. In circular motion, the angle between velocity and radial acceleration is, radial acceleration means centripetal acceleration. This is the second name of centripetal acceleration. What is the second name of centripetal acceleration? Radial acceleration. Tangent radial acceleration is always towards the center, means along radius. Centripetal acceleration is along radius. So this is the centripetal acceleration. This is over here. This is the centripetal acceleration. So when this is the centripetal acceleration and this is the velocity vector, what is the angle between them? The angle between them is 90 degree. Okay. Now the same proof we are going to discuss. The proof which we discussed just some time before, that is V A equal to V omega R omega square and V square by R. Same proof we are going to discuss, but with calculus method. Calculus method means derivative and integration and limit. Over here we are not going to use huge knowledge of vector addition or any triangle law of or like that. So again the description is same. Consider a particle performing UCM in anticlockwise sense. Initially particle is at point A. After some time particle will reach at point P by covering angle theta. But we are knowing one formula. When we are going to mention about theta, we are knowing this formula, omega equal to theta by t. So what will be the formula of theta then? Can I write theta equal to omega t? And omega means angular velocity. Angular velocity means angle upon time or angular displacement upon time. So angular displacement is equal to angular velocity into time, omega t. Okay. Then further, let vector r, this is vector r. Over here we are going to use the resolution of vectors. Any vector we can resolve into two components, along x-axis and along y-axis. Is it right? So along x-axis component is OS, that is x component, and y-axis component is OT. So vector r we can resolve into x component and y-axis component, x and y. So vector r is equal to x vector I plus y vector j, where I and j are unit vectors along x-axis and y-axis respectively. So vector r is equal to I r cos theta. Now you may ask me, sir, how you can write it is I r cos theta at the place of x. I substituted r cos theta. See how I am going to write. Pay attention over here. This is theta. Can you tell me formula of cos theta? The very basic formula of cos theta is adjacent upon hypotenuse. Adjacent is this x. X is the adjacent. And hypotenuse is, that is OP. OP means R. So R. So x equal to R cos theta. Is it right? X equal to R cos theta. Therefore, at the place of x, I substituted R cos theta. Similarly, at the place of y, I will substitute R sin theta. How? See. What is formula of sin theta? Opposite. Opposite is PS. So sin theta is equal to PS upon R. But is PS and OT are same? Are these two lines are having same value, PS and OT? Yes. So as PS and OT means Y having same value, I can write Y upon R. So Y equal to R sin theta. So at the place of Y I substituted R sin theta. So vector R is equal to vector I R cos theta plus vector J R sin theta. But as we discussed, theta equal to omega t, is it right? So putting omega t over there, vector R is equal to R you can take outside common inside a bracket, I cos omega t plus J sin omega t. Now what I want to find out? Want to find out acceleration. So before finding out acceleration, I want to find out velocity. So R is the distance, is it right? Actually radius, but something but a distance. Then differentiating it means by taking its derivative with respect to time. So distance upon time is nothing but a velocity, no? So differentiating V equal to d by dt R is equal to R you can take common. So sorry, you can substitute this value over here at the place of vector R, that is R I cos omega t plus JR sin omega t. What is the derivative of this value? What is the derivative of cos theta? Cos theta is minus sin theta. But over here we are going to use chain rule. You may ask me, sir, what is this chain rule? See, pay attention. Suppose there is any value, that is sin t, suppose, then according to chain rule this 2 will come outside and your derivative's value is 2 times derivative of sin is cos 2 cos 2t. According to chain rule, this 2, the value attached to t will come outside. I am working with derivative just now. So sin 2t, you can, this 2 is attached to t. Similarly, over here, omega is attached to t. Omega is attached to t, which will come outside. Derivative of cos omega t is sin omega t. And derivative of sin omega t is cos omega t, and this omega will come outside. Again, I will repeat a complete part. See. According to the knowledge of scalars and vectors, vector R you can resolve into two components along x-axis, along y-axis. X-axis component is xi, vector I, and y-axis component is y vector j. Then this x, what is formula of cos theta? Cos theta is adjacent is x divided by hypotenuse is r. So x equal to r cos theta. So putting r cos theta. Similarly, what is formula for sin theta? Sin theta is equal to opposite upon hypotenuse. So y equal to r sin theta. So over here we are going to put r sin theta. But theta is omega t. So substituting omega t and omega t over here, then differentiating of this position vector will give us linear velocity. Means we are going to differentiate, means we are going to take its derivative. So taking its derivative, what is the derivative of cos omega t? Derivative of cos theta is minus sin theta. But according to the chain rule, if anything is attached to theta or anything attached to the time, that time will come outside once. So cos omega t is minus I omega, I as it is, minus I omega sin omega t. Similarly, derivative of sin omega t is cos omega t into omega. Okay, so cos omega t into omega, sin omega t into omega. This is velocity. This is velocity. We want to find out acceleration. Is it right? So to find out acceleration, again I am going to take derivative of velocity. So what is the derivative of r as it is? Again, is it right that from initially we are carrying this r? So what is the derivative of sin omega t? Derivative of sin omega t is cos omega t into omega. So cos omega t into omega, but already one omega is present, so that omega and one more omega, it will become omega square. Similarly, what is derivative of cos omega t? Cos omega t is minus sin omega t into omega. So minus sin omega t into omega, but already one omega is present, so omega into omega is omega square. From this we can take this omega square outside. After taking omega square outside, and minus sign also we are going to take outside, so omega square over here plus and multiplying with r inside, so it will become ir cos omega t plus jr sin omega t. Check over here, what is ir cos omega t? See, ir cos omega t and gr sin omega t, what is this? Is it vector r? Yes. So our formula will become, at this place we will put vector r and our formula will become minus omega square vector r, or that is equal to minus omega square r unit vector r. What that minus sign will indicate? Minus sign will indicate direction of this acceleration. Direction of this acceleration and direction of this r are exactly opposite. Direction of radius vector, where this radius vector is moving, check over here. Is that radius vector is moving away from center? Over here, yes, it's moving away from center. Radius vector is moving away from center. So obviously this acceleration will move towards the center. Everybody getting this proof? If you are getting this proof, please click on agree. If you are having any doubt, you can ask it to me. Okay, very good. I will proceed further towards next slide. That is, suppose the motion is not UCM, not uniform circular motion. If it is not UCM, then also there is centripetal acceleration. So there is centripetal acceleration, and this is the tangential acceleration. So both accelerations are present at a time. When both accelerations are present at a time, can we find out resultant acceleration? Yes, we can find out resultant acceleration. How can we find out resultant acceleration? We can find out resultant acceleration. See, when this is 80, this is also 80. This angle is 90 degree. So this is resultant acceleration, and resultant acceleration A, vector A. Can I use Pythagoras theorem? A square is equal to 80 square plus AC square. So when 80 square plus 80 square, obviously A equal to under root AC square plus 80 square. So this is the resultant acceleration. Now I will move towards Mina's question. In vertical circular motion, you will find both accelerations, centripetal acceleration as well as tangential acceleration. For example, hand of a clock. It is moving like this way. So in this situation, both accelerations are present: centripetal acceleration or tangential acceleration. In case of giant wheel, in giant wheel also both types of accelerations are present, centripetal acceleration and tangential acceleration. Okay. As there is centripetal acceleration, there should be the centripetal force. As there is centripetal acceleration, there should be centripetal force. So, what is the formula of force? Mass into acceleration. So, centripetal force is equal to mass into centripetal acceleration. So, mass, what is the formula for centripetal acceleration? Minus v square upon r. So, minus mv square upon r. Minus r omega square. So, minus mr omega square. And minus mv omega. These three formulae are there for centripetal force. Minus mv square upon r, minus mr omega square, and minus mv omega. Revolve around Earth when satellite is revolve around Earth in circular orbit. Gravitational force between satellite and Earth will act as a centripetal force. Gravitational force will act towards the will attract that satellite towards the center of Earth. Gravitational force will attract that satellite towards the Earth. So, gravitational force is equal to centripetal force. When anything is moving in circular orbit, then velocity is in this direction and centripetal force always towards the center. We discussed this example, David's sling example. This David is going to revolve it like this way, revolve the sling like this way, and when David is going to revolve the sling like this way, he will stop. So over there is development of tension in between a stone and a thread, or where he is going to hold. So that tension is responsible for centripetal force, or over here tension will act as a centripetal force. In force example, which thing will act as a centripetal force? In force example, gravitational force will act as a centripetal force. In second example, tension is responsible for centripetal force. Next, over here again gravitational force. Over here, sir, what about the rotating tire? In case of rotating tire, the molecular force between those tires is going to develop the necessary centripetal force. All these things about rotating tires and rotational motion we are going to discuss in our third chapter. Okay, so we are just discussing the circular motion, not rotational motion. Now you may ask me questions, what is the difference between circular motion and rotational motion? See, I will give you a simple example. Suppose it is moon. Moon is revolving around Earth. Circular motion. Moon revolving around itself. Rotational motion. Tire is going to revolve like this way, no? So motion of a tire is which type of motion? Rotational motion. So rotational motion we will discuss at that time. Over here, electron are going to revolve around proton. So when electron will revolve around proton, there which force is present in between positively charged proton and negatively charged electron? Which force is present? No, not nuclear force. Nuclear force is inside the nucleus there. Over here, electrostatic force is present. In between electron and proton, electrostatic force is present. So electrostatic force is responsible for centripetal force. Electrostatic force is responsible for centripetal force, and therefore in chemistry, 11th standard chemistry, chapter number 3, atomic structure, there are Bohr's postulate, is it right? So first Bohr postulate is electron revolve around nucleus in circular orbit, and over there centripetal force is equal to electrostatic force, centripetal force CPF is equal to electrostatic force. So Bohr stated it with the help of this centripetal force concept. Stated the first postulate with the help of this centripetal force concept. Okay, over the here, these two girls are moving round and round and round. When these girls are moving round and round, again the tension developed over here is responsible for centripetal force. Okay. Now, what is Newton's third law of motion? For every action, there is equal and opposite reaction. So centripetal force is the action. When centripetal force is the action, centrifugal force is the reaction. Centripetal is action, centrifugal is reaction. Obviously, centripetal force will act towards the center. Is it right? Centripetal force will act towards the center. In which direction centrifugal force will act? Centrifugal force will act away from the center. Centrifugal force is because of non-inertial or accelerated frame of reference. Centrifugal force is an imaginary force or pseudo force. What is pseudo force? We discussed in 11th standard. The force which we can feel. The force which we can feel, but we cannot see the cause behind it, is known as centrifugal force. Is it right? Sorry, is known as pseudo force. Now, over here, suppose you are inside the bus and bus is taking sudden left turn. What you will experience? You will experience rightward push. When bus is taking turn towards left side, you will experience rightward push. Is anybody pushing you towards right? Nobody is pushing you. Then also you will feel that force. You will feel that force because of centrifugal force. You will feel that force because of centrifugal force, which is pseudo force. So what is the definition of this centrifugal force? This is, first of all, imaginary force acting on the body in UCM along the radius. Again, it will along radius. Centripetal force is along radius but towards center. This force is also along radius but away from the center, having same magnitude as that of centripetal force. Why same magnitude? Newton's third law of motion, for every action there is equal and opposite. So equal. So say value of centripetal force and centrifugal force are same. Values of centripetal force and centrifugal force are same. Only directions are opposite. So imaginary force acting on a body in UCM along the radius away from the center, having same magnitude as that of centripetal force, is called centrifugal force. So formulae are same, but you can observe over here, is minus sign is present? No. So mv square upon r, mr omega square and mv omega. Then see, this is one example. When in bike race, driver going to lean inside at the time of turning. Why driver used to lean inside at the time of turning? For time pass? No. Then see, when driver, suppose driver is going to turn his vehicle as it is, then what will happen? When he is going to turn, he is turning, means he is performing which motion? Circular motion. So obviously whenever there is circular motion, there is centrifugal force. Is it right? So driver is turning, see, driver is turning like this way. So centrifugal force will try to push the driver towards this side. Centrifugal force will try to push driver towards this side. What will happen if driver will get pulled towards this side? Pushed towards this side, then he will fall down. So to nullify the effect of centrifugal force, driver used to lean inside while driving the vehicle. Okay. Two examples we discuss. First, you are inside the bus and or any vehicle, four-wheeler, and vehicle is going to take sudden left turn. You will experience push towards this side. That is because of centrifugal force. Driver will lean over here because of centrifugal force. Are we going to use this centrifugal force? Yes. So just discuss uses of centrifugal force. Actually, I want to show you a few videos also, but today there is very less time. As lack of time, I will not show you videos in today's session, but definitely videos are there with me, but hardly 5 minutes are there with us. So videos we will see in our next session, that is on Monday, same timing 9 o'clock. So we will start with videos only at 9 o'clock. So be present sharp exactly at 9 o'clock. Okay. Before finishing, I want to discuss the uses quickly. So see, first use is centrifugal machine. Have you seen this machine in your chemistry lab? In your chemistry lab, okay. So if you not seen, many higher colleges, means BSc level colleges, having this machine in their colleges. What you have to do? We are going to use this machine to separate precipitate. You are going to call it as PPT. Is it right? We are going to put these test tubes inside these two holes as shown over here. See, over here and over here. Solution is present, and we are going to start rotating this knob. So as you are going to rotate this knob like this way, this test tube, so suppose these are rod test tubes are over here, this part also will start rotating like this way. So when it will start rotating like this way, this test tube will become horizontal slowly. When this test tubes will become horizontal, see, this is the center. When test tubes will become horizontal, centrifugal force will act in this direction and in this direction. This centrifugal force will push all these particles towards bottom of the test tube, and therefore precipitate PPT will get collected at the bottom of test tube. So if you want to use the liquid part, take that liquid in beaker, wash out the precipitate. If you want to use precipitate, then throw that liquid and you can use precipitate which is already present at the bottom of the test tube. Getting it? Like this way, we are going to use this centrifugal machine. See, there are n number of examples. This is washing machine which is in front of you. In washing machine dryer, we are going to use centrifugal force. You may ask me, sir, how? See, very simple. It is going to rotate like this way or like this way. When it will, have you seen the dryer of washing machine? Over there, holes are present. Is it right? Holes are present to the walls. When it will start rotating, suppose like this way, centrifugal force will get created at the center and it will act away from the center. So the centrifugal force will throw all clothes towards the wall of the washing machine, and clothes will get pressed between wall and centrifugal force. So as clothes will get pressed over there, what will happen? Water will come out and it will move away from those holes present to the walls, and then it will then water present over there will get drained out, and because of that large centrifugal force, your clothes will become very dry than your actual or your hand wash. This pump which is present over here is nothing but centrifugal pump. In engineering, you are going to study the detailed structure of the centrifugal pump. There is a subject for engineering, as I used to teach for engineering students. There is a subject for engineering students. The name of that subject is fluid mechanics. and applied physics or applied mechanics. Over there, you are going to discuss the centrifugal machine. You are going to discuss this centrifugal machine. The name, sorry, centrifugal pump. The name itself is having the word centrifugal. Okay, so because of the centrifugal pump, water will rise from bottom to top. Okay, then next, see, this is a cream separator. One question, sir, centripetal force and centrifugal force are equal and opposite, so they cancel each other. No. Why they will not get cancel each other? Because centrifugal force is a reaction force, my dear friend. Centrifugal force is because of reaction. Is it right? So whenever there is action and reaction force, it will not get cancelled. See, are you going to think like this way? If you are going to slap anybody, and suppose so you slap, so that is the action. So another person is going to slap you again. That is the reaction. So are you going to say there is no effect now? I slapped him, he slapped me, so there is no effect to me. No, no, you cannot say like this way. Is it right? So similarly, whenever there is action and reaction force, you cannot think about this cancellation. Okay, this part, that is cream separator. In any dairy, you can see this cream separator. Any dairy or milk. From milk, you are going to separate the cream, or from buttermilk, you are going to separate butter. See, same principle you are going to use. When you are going at your house, you are going to do this process, no, to separate butter from buttermilk. When you are going to do, what will happen? At the center, there is a development of centrifugal force. The centrifugal force will push cream towards the walls. Now why cream only? Because cream is having more mass, or cream is more heavier than milk or buttermilk. So cream or butter will get thrown towards the walls of the container. So this is the first developed cream separator machine, where we use this centrifugal concept, and this is the now very new centrifugal machine with which we can separate cream or butter, okay, with the help of centrifugal force. See, this is one old cannon which was working on centrifugal force. See, in sugar industry, these are centrifugal machines present in sugar industries to separate the juice of sugar cane and actual sugar from each other. So sugar will get thrown towards the wall, and you can separate different types of sugars with the help of this centrifugal machine. One question, the force acting on particle performing UCM along radius of circle directed towards the center, centripetal, centrifugal, sorry, option is centrifugal, centripetal, gravitational, electrostatic. Yes, Ashish typed correctly, that is centripetal force. Next, if particle is moved through half a circle of radius r with constant speed, then kinetic energy increases, kinetic energy decreases. Means particle is going to travel like this way. What about kinetic energy? It will increase, decrease, remain constant, or it is zero? Remains constant according to Sridhar and Ashish. No. Answer is it is zero. How it is zero? I will explain. Two different concepts I am going to discuss with you over here. Kinetic energy is nothing but the work done. Isn't it? What is formula for work done? Work done is F, force, into displacement, S, cos theta, Fs cos theta. Can you tell me the angle between force and displacement? Force, centripetal force, obviously. Centripetal force is towards the center. Is it right? Centripetal force is towards the center. And displacement is like this way. Yes, along tangent. Displacement is along tangent. So angle is 90 degree. So substitute over here. Cos 90 is how much? Cos 90 is 0. Is it right? So obviously work done is 0. So kinetic energy is 0. So the answer is 0. And same question almost. The centripetal force acting on particle performing UCM has no work done, maximum work done, minimum work done, none. As we discussed just now, what is the correct option? A, correct, no work done. Very good. Force, option, sorry, kinetic energy remains constant. This is wrong. I am very sorry. It is 0 only and no work done. Obviously, there is no work done, there is no kinetic energy also. Okay, this is the homework question. Note down this homework question, and first question is for you. This is from our next session. Okay. So today we will stop at this moment.